Good morning and welcome to the video for Friday, January the 8th. This is going to be a lesson for fourth grade working through lesson 6.8 from Go Math. So today we're going to be working with comparing and ordering fractions. So if you are not comfortable with finding common denominators, using benchmarks to do comparisons, which was a lesson that we've done recently, you need to go back and take a look at those lessons before you try to do this. Not trying to be mean, but if you're still struggling with that idea, you need to go practice that idea. And one of the reasons I'm glad that this lesson is on a Friday is that can give you some additional time to work on this over the weekend, kind of get caught up to what we're doing, because I am not going to move quite as slowly because both of those ideas are new. The only thing that we're doing differently today is going to be part of working with placing them on a number line, but also working to compare three things instead of just two. And so all of the steps that we're going to use today really depend on you being comfortable with being able to find equivalent fractions using common denominators and our strategies for that, and then being able to use benchmarks to make things easier. And so, for instance, for our unlock the problem, we are going to be able to use benchmarks to find the answer. I know there's a part with step 2 and it says that we're talking about doing a common denominator. I'm not even going to do that. The easiest strategy to find the answer for this is to use our benchmark fractions, okay? So we're going to work with that. So we are working with 3/5, 1/12, and 9/10. So here are our benchmark fractions. So what is half of 5? Pause the video if you need to think about that for a moment. What number would be half of 5? And so if you've had a chance to think about that, it's going to be a number that falls between 2 and 3. So 2.5 is the actual answer. We normally can't use that yet. When you get into 7th grade, you'll be allowed to use fractions as part of other fractions or decimals as part of fractions. But until then, we're not allowed to do that just yet. So what we're looking to do is say that this side, 3/5, since it's larger than 2.5 parts out of 5, is going to be greater than our benchmark fraction. 1/12 is going to be really close to 0. So we're nowhere near close enough to be halfway on that one. And so that should suggest that this one is going to go up here. And then 9/10 is almost a whole. It's just one part away from being a whole, but we're working with really small parts. So we're very, very close to being a whole. So this one is going to go up here because it's almost at a whole. This one is just barely bigger than 1/2. And so this one would go up here. So 3/5 will go right here. So there will be quite a few times that we can use just this strategy to find out what the answer should be if we're putting them from least to greatest or greatest to least. There might be times that we can get one part of the three sorted out by using this strategy, but we need to find a common denominator for the other two. And so that's where this part comes in. We can definitely tell that this is the smallest. Now, normally we should also be able to tell that this is the largest one, but the reason why they had this in there, they wanted us to be able to find a common denominator. So I will do that really quick because that is something that we will need to do during this lesson. So to get from parts out of 5 to parts out of 10, I need to multiply by 2. So my top and bottom number are both going to be multiplied by 2. And so when I do that, I get 10 for the bottom, and then 3 times 2 would give me 6, which would let me know that 6/10 is going to be less than 9/10. And so because both of these were bigger than 1/2, we might use that as a tiebreaker. I normally just say, as long as we know that one of them is actually closer to being half or closer to being a whole, we can go ahead and compare those two just by using the benchmark fractions. But there will be some cases that we can't do that. So let's move on to our next page. And so now we're working actually with 4 of them. So we want to compare each fraction to 1/2. So 1/3 is going to be smaller than 1/2, because again, we're working with smaller pieces here and we're only counting one of them. So that is going to be the one that's less than 1/2. All the other 3, as you can see on the number line, are all going to be greater. So we could go ahead and write these other 3 that are greater. So 1/3 is going to be the smallest fraction that we have, and it tells us to go ahead and put that on the number line. That would go right here. So now we're going to keep going. We're going to figure out what the difference between 7/10 and 7/12 and 8/10 would be. Now, I can go ahead and say that 7/10 is definitely smaller than 8/10, but I don't know about the 7/12 part. So in this case, I can go ahead and compare these two. They have a common numerator. So my amount that's greater is going to be the one that has the larger pieces. So the smaller the piece is, the more pieces there are, the smaller the piece is. The less number of parts there are, the larger each individual part is. And so if I'm counting 7 parts out of 10, I'm counting larger pieces here compared to smaller pieces here. So this one is going to be greater than this one. And this was something that we learned last year, and we've practiced it a little bit, but in case you didn't get to this, for instance, I have some students that transferred from a different school for this current school year. So you guys may not be as comfortable with that. That was one of the things that we worked on last year. Now, we know that 7/10 is going to be larger than 7/12. We're comparing these two. I'm counting parts out of 10 for both of them. And so this side is going to be larger. So 1/3 is going to go first. That's our smallest one. Our next largest one is going to be 7/12 because this one is smaller than this one. Then our third largest one would be 7/10, and our largest one would be 8/10. Now that covers doing most of what we're going to work with. There's going to be a couple times that we're going to have to find equivalent fractions because we're counting the same number of parts, possibly. Let's go ahead and do this and move the page over. I'm going to skip that example at the bottom. We have lots of these examples, so I'm not going to use all of them. If you want extra practice, you are welcome to do all of these problems. I would definitely encourage that you do that. But in the interest of making this video short enough that everybody can understand what we're doing and be able to pause and work along, I would definitely recommend that if you need extra practice, I will leave extra problems for you to practice and try to, get comfortable with what we're doing here today. All right, so I will do one more of these because this is the last one of these problems that shows up, I think, except for the homework. So we are doing 3/10, 11/12, and 5/8. So on the previous page, the first thing we did was try to compare to 1/2. So I want you to think about which of these fractions is smaller than 1/2, which ones are larger than 1/2, and if there's one of them that might be almost a whole, okay? And then we can use those benchmarks to help us figure out what the answer could be, all right? So pause the video, go ahead and try to figure out which ones are smaller or greater than 1/2. And then if we have one that's almost a whole, and when you're ready, go ahead and push play and we'll figure out how to plug those in. All right, so assuming that you did that, and hopefully you did, assuming that you didn't already just look at this and be like, hey, I know exactly what I'm doing here, and went ahead and took down the answers. So 3/10 is going to be our one that is less than 1/2. I would need 5 parts out of 10 to be exactly 1/2. So our 3/10 is going to go right here. And then we need to figure out the other two. So 4 parts out of 4 parts out of 8 would give me exactly 1/2 for this one. So we're a little bit bigger than that. And then 11 parts out of 12. So 6 parts out of 12 would give me exactly 1/2. So we're almost at a whole for this one. So this one should be going over here, because without even having to worry about finding an equivalent fraction, we are missing a very small amount from this shape to get to the whole. This one is almost exactly 1/2. It's just 1 part bigger, and we're working with kind of medium-sized parts on that. So 5/8 is going to be our one that goes here. And so to kind of recap that, so I found the one that was the smallest because it's less than 1/2. Then I found the one that's the largest because it's closest to being a whole. And then this one ends up going in the middle because that's all that's left. Also, I could say that this one is actually the closest of all of these to being exactly 1/2. So I'm 4 parts out of 8 would give me 1/2. I would need 2 more parts to get up to 1/2 here. And I would need to take away 5 parts here to get backward to 1/2. Okay, so let's go ahead and do number 2. I'm going to go ahead and ask you to pause the video. Once I'm done explaining, you can go ahead and try this on your own. So we have 2 parts or 2 fractions that have the same number of parts for the denominator, so we're counting parts out of 10. So you have 2 options. You can use a benchmark fraction to compare 1/5 to 1/2, and then compare these to 1/2 to figure out where this should go. Or you can go ahead and change this fraction to parts out of 10, which should be really easy because we can count by 5s 2 times to get to 10, and we can multiply this by 2. And then we can make all 3 of them parts out of 10. So use one of those 2 strategies, pause the video, go ahead and come up with your answer, and when you're ready, hit play. All right. So assuming that you did that, let's go ahead and say the benchmarked fraction, 1/5 is going to be smaller than 1/2. So if we're counting 1 part and only 1 part, the larger this number is, the farther away and closer, the closer to 0 we get compared to the closer to 1. So if I'm using this starts at 1/2, and then 1/3 would be like here, and then 1/4 would be here, and then 1/5, 6th, 7th, 8th, 9th, and we get progressively closer to 0 as we add more parts on the bottom that make up the shape, because each time it's going to mean that the piece that we're actually counting is getting smaller and smaller when we do that. So 1/5 is going to be the smallest. And then the remainder is to compare 7 to 9. Oh, sorry, they actually want you to write the greatest value. So I'm doing something slightly different. I asked you to do something slightly different. So I'm going to show you this as the comparison, and I'll circle the one that should have been our correct answer. My apologies for not reading that closely enough. So as we go ahead and do the next ones, we'll make sure that we do that correctly. But so in the order that I would compare them to find the answer, 9/10 would become the largest one. So let's skip over to this one now. We are looking at 2 parts out of 8, 1 part out of 8, 2 parts out of 4, and 2 parts out of 6. So we can use benchmark fractions. So one of the things that we can do is figure out which one is closest to 1/2. It doesn't look like we have anything that would go past that. So we're either smaller than 1/2 or at 1/2. So one of the things that we could do is we could probably go ahead and rule these 2 out, because we have 2 parts that we're counting, and we have smaller numbers, which means we're counting larger pieces. So there's going to be more here and more here than what we'd have with either of those two. So from there, we can go ahead and compare these two. So which one of these two fractions between 2/4 and 2/6 would be our largest fraction? And that's the one that we want to write down. So pause the video if you need to think about that for a moment, and when you're ready, go ahead and hit play. So again, we're removing these two from consideration because they're too small compared to both of these. And so 2/4 is going to exactly be 1/2. So 2 is exactly half of 4. So this one is worth 1/2. This one has slightly smaller pieces. So when we're counting the two pieces, we're not counting quite as much as we would count here. So our answer for that one would be 2 parts over 4. And that's a really bad looking 2. Sorry about that. All right, let's go ahead and do number 5, which was what I thought we were doing when we were up here. So I want you to look at those three fractions, and I want you to see if you can figure out which one automatically has to be either the smallest or the largest because of what we're working with. Okay, so go ahead and pause. I'll let you choose either one of those two. And when you're ready, hit play. And then we can go ahead and figure out from there what we can do to find the rest. So the one that sticks out to me the most is actually going to be this one, because we are counting 3 parts out of 6. So if I went ahead and changed this, this is going to give me exactly 1/2. And so that's going to be my largest fraction, which means I can now figure out I meant to put the 1/2 in parentheses, but we're actually writing 3/6 here. So the 3/6 part's going to be worth exactly 1/2, and then so 1/4 is going to be smaller than 1/2, and 1/8 is going to be smaller than 1/4. Okay. So let's do number 7 now. We have two that are the same denominator, and we have one that's different. So we can change this one to make it into parts out of 12. So I want you to go ahead and do that. And then once you're done, go ahead and put these in the correct order, and then you can unpause the video when you're done with that. So go ahead and pause. Let's find our equivalent fraction for 3/4 with parts out of 12, and then go ahead and plug in our comparisons. So when we do the comparison part, we are going to do 3/4. Again, having difficulty writing today. And then we are going to do this. So I can count 3 times by 4 to get to 12. So 4 times 3 gives me 12. It looks like either zooming out will fix that. So you can see all of this. So we're going to do 3 times 3 for the top number, 4 times 3 for the bottom number. That is going to give us an equivalent fraction of 9/12. And so now I can compare. So 5/12 compared to 7/12 compared to 9/12. So in that order, so 5/12 is going to go first, 7/12 is going to be in the middle, and then our 3/4 is going to be the greatest. I notice I'm starting to run low on time, and I still want to go over a couple more problems and do the homework and still keep this at a reasonable level. So instead of writing, I am going to draw if I can. Let me look at the homework real quick and make sure we don't have to do anything like what's on the bottom. Okay, so oh yeah, I really did put evens on the front. Yes, okay. I really meant to do that. Okay, so that means we're going to have to do number 8, which means some of you may need a little bit of time to work on that. So I will explain that here in just a moment. So we're not going to have to worry about plugging in a numerator. That would be something, if you're really comfortable with this and you want some extra practice, you can send me a message. You can go ahead and work on these and ask if you have the right answers, and I'll let you know. But I want to do one more of these. I want to do one that we don't have something quite as easy to work with. So let's do, actually, I think either 8 or 9 are both good. We can use our benchmark fractions to help us. So let's do number 9. I want you to figure out if there's one of these, or actually, let's just compare all 3 of them to 1/2. So let's start with 4/8. Is 4 half of 8? If yes, then we're exactly at 1/2. If 4 is larger than half of 8, then we're larger than 1/2. If it's smaller, then we're smaller than 1/2. So is 4 exactly half of 8? The answer is yes. So this one is going to be exactly worth 1/2. Now, 5/12. How many parts out of 12 would we need to be exactly at 1/2? So think about that for a moment. We should actually have 6 parts to be at 1/2. So as we're comparing, right now, this is our largest one, and this one would be right next to it. And then what about 1 part out of 6? How many parts out of 6 would we need to have half of 6? And the answer to that should be 3. So this is going to be our smallest one. It's the furthest away from 1/2, but it's also our smallest one. It's actually almost closer to 0. Then we have 4/8, which is going to be worth exactly 1/2. And then our 5/12 is going to be the largest, being just slightly larger than 1/2. So we use just benchmark fractions to figure that out, okay? And that's a really good strategy. It can save us some time. So if you want some extra practice, I would, recommend going ahead and doing these. This one's actually really easy, so I skipped over that. So this one obviously has to be the smallest because we're counting 7 incredibly small parts, and then we can go ahead and compare these two by changing this to parts out of 10. So if you choose to do that one for extra practice, that would be what we would be looking to do. So number 2, we could possibly use our benchmark strategy to do that. That might be a good choice. Now, keep in mind, this part is going to be, both of these are kind of close to 1/2. So we need to find a common denominator for 3 and 8 that might work for us. And then we can use our multiplication strategy to figure that out if we need to do that. Number 4, we're going to do that problem as well. Again, we can start with benchmark fractions. We might be able to go ahead and make this fraction into parts out of 12 to be able to help compare these two. Number 6, we have 3 fractions. It looks like we can use benchmark fractions to help us figure that out. I don't know why I changed colors there. Number 8, how is ordering fractions on a number line similar or different from ordering whole numbers? So let's look up here. Let's say that we're looking at this problem. How is comparing all of these using a number line similar to comparing just whole numbers? And how is it different? So for instance, this is not the best example, but we're using a benchmark fraction in here. So I am counting larger numbers on the top. That doesn't necessarily mean that that's always the way it's going to work. Like for instance, I could say that this fraction here was 4/5, and then I'm doing 4 on the top. And so I'm going from 2 to 5 to 4, which means I'm not getting larger with the top numbers I go across. But we are getting a larger value. So if you can kind of understand how that works, that might give you a hint on how it's different. And then on the back, I want you to go ahead and do all of these. So this one should be really easy. We have benchmark fractions that can help us on number 1, benchmark fraction, and then we can compare these two using the size of each part that we're counting to compare And both of these are going from least to greatest, which is great. That makes it a lot easier. We're not switching back and forth between, oh, we want you to start with the largest one now. Now we want you to start with the smallest one. That's where I usually see people make mistakes. So all of these I'm giving you, we're going to put the smallest fraction first, and then we're going to work our way up to the largest. Oops, I didn't mean to do that, although that could work. Number 3, we are dividing the number of cents by the number of nickels. So think about how many cents a nickel is worth, and then we are dividing to figure out the number of those coins that we have. Let's see, 3 classes that each last 15 minutes. That should give you a suggestion of what type of problem we need to do if we're going to find the total amount. So there's 2 different ways we could do that. Number 5, which one of these numbers is not a composite number? So to be not a composite number, that means we have a prime number. And a prime number is a number that can only be divided by 1 and the number itself. Number 6, we want an equivalent fraction with parts over 4. So it looks like we're actually going to reduce this fraction. So figure out what type of problem we would do to get from 8 down to 4, and what number we would use in that problem to get from 8 to 4, and then we do the same thing to the top. So those are the problems for today. I know this is a longer video, so hopefully everything makes sense. If it doesn't, again, before you really get into this, especially on the homework, go back and look at those earlier lessons to get some suggestions. You could even go back and watch some of the more recent videos that I've done for the 2 previous lessons to get more explanation. But I think I've explained everything pretty well. You can also ask me questions on Google Classroom. I'll be happy to help with those. And again, you have the entire weekend. So if you're watching this and it doesn't click right away, take a break, go do something else, come back to this with kind of a fresh energy, clear your mind, and let's try it again. You guys will be able to successfully do this, I promise. Just take your time, don't rush, don't give up if you get frustrated the first time that you're trying to do this, all right? Have a great weekend, and I will see you on Monday.